Assalamu alaikum, dear student. Here it's me, Mohammed Siddiq Bechni. Today in this short video lecture, we would be talking about rational and irrational numbers. More importantly, we will prove that is phi rational or irrational number. If it is rational, so why it is rational? If it is not rational, so why it is not so? So let's proceed. So what are a rational number? Okay, these are numbers which can be written in the form of p upon q. What does this mean? Okay, here p is integer, q is also integer. Now the thing that is okay, what basically integer means? Integer means a complete number, okay, which is not in a decimal form. This is a integer, okay, 2. 3 is integer, 5 is integer, but 0.2 is not a integer. This is a decimal, okay. So these are integers, okay. Rational numbers are the numbers which can be written in the form of p upon q, where p and q are both integers, okay. Now there are many students, okay, who are quite confused regarding rational and irrational number, especially when they look at the value of phi. So today in this lecture, inshallah, I will be trying to demolish this confusion. So these are integers, okay. Now let me tell you, okay, this is something different, okay. Suppose I have a rational number, okay, 2 by 3 with me, okay. This is a rational number, okay. Why this is a rational number? Because this is an integer, this is again integer, and this is a fraction of two different integers, okay. And these two are relatively prime integers, okay. I will be telling you ahead. So whenever I have a number with me, okay, like 10 by 5, this is again integer, okay, or 10 by 15. These are again integers and called a rational number. Now the thing is that, okay, this is not in its lowest form. Why it is not so? Because this is, we can cancel these 10 and 15 with each other, okay. They are multiple of 3, both numbers, okay, or we can say, multiple of 5. So what I would be doing, I will write 10 as 5 multiplies with 2, and 15 as 5 multiplies with 3. Is it fine? So 5 will get cancelled with 5. This will be again 2 by 3. So what I was trying to tell you, okay, this integer 2 by 3 and this 10 by 15, these both are, okay, same rational number. This is in lowest form, this is not in its lowest form, okay, this fraction. So this is a rational number, this is also a rational number, both are same rational numbers. Now what I was trying to tell you, okay, relatively prime integers, okay, this is integer, this is again integer. What are prime integers? Prime integers are those integers which have only two factors, okay. They are, okay, one is itself and the second is 1, okay. Suppose I have a number with me, okay, that is 5. 5 is two factors, okay. We can divide 5 either with 1 or with 5, okay. So 5 has only two factors, so this 5 is called prime integer, okay. Now relatively prime integers are the integers which do not have any common factor, okay, except 1. These are the integers which do not have any common factor except 1. Try to write definition as I am telling you guys orally. So these are the integers which do not have any common factor except 1, like these two integers, okay, 2 and 3, okay. 2 is integer, its factors, okay, that is 1 and 2. Similarly 3 is its factor 1 and 3. So these integers have only one common factor, that is 1. Except 1, they do not have any other common factor. So that's why these two are called relatively prime integers. Now the question is, okay, decimal representation I will be telling you guys in next video. Or let me tell you, because this is quite important to understand why phi is a irrational number. So decimal representation of rational and irrational number. Decimal representation. Okay, now look, if we are given numbers in decimal form, we will be trying to identify whether these are rational or irrational number. There are few rules. Okay, you will have to keep these rule in your mind. Okay, when it is terminating and recurring, sorry, only terminating, this is the second case. When we have terminating decimals, okay, what does terminating decimal means? Terminating decimal means which ended, okay, whose decimal part ended after 10, 15 or any number of digits, okay, like 2 by 3. So one decimal place is there. 2.3 is terminating decimal. 2.3334 again are terminating decimal. These kind of decimals, okay, which terminate after 2 or 3 places, so they are called terminating decimals. So all terminating decimals are rational number. Okay, second case is there, all non-terminating. Okay, non-terminating means they are not terminating and keep on going. Non-terminating and recurring. So what recurring is? Recurring means which occur again and again. Okay, suppose in the case of 20 divided by 3, we get the answer 6.333. okay, this is going on. Okay, we will be getting this 3 again and again. So this 3 is recurring decimal. Okay, this one. So what will be the answer? 6.3. okay, we can notify this. Okay, recurring, the number which is recurring, either if it is two digits, 3 digits, single digit, no matter at all. Okay, but this need to be a reoccur. Okay, as in the case of 22 by 7, I will be telling you ahead. So we put a bar over it. Okay, it means that this 3 is coming again and again. So all the non-terminating, okay, which are not terminating, means they are going on. Okay, so this 3 is going on, but recurring. Okay, this is recurring. Non-terminating and recurring are again rational number. Okay, so all these type of decimal will be counted in the category of rational number. So the last final case, okay, that is non terminating and non recurring. Okay, non terminating and non recurring So non-terminating, okay, the decimals which are not terminating. Okay, it means that they are going on to infinite decimal places. And non-recurring means it is not reoccurring. Okay, like suppose I have 2.374878 2 7 5 like 6 3 2 1 0 5. Okay, now this is going on. Okay, 2.37. okay, here is 3 7 4 7 4 8. all these are different decimals. Okay, so none of them is okay reoccurring, like in the case of 6.3. okay, recurring is of that point, of this kind. Okay, 6.23723 5 2 3. okay, this 2 3 is recurring. Okay, 2 3 is recurring. After that, okay, again 2 3 is recurring. Okay, is it fine? So these are kind of recurring decimal places. Is it fine? Or let me give you some proper example. This will be quite confusing. 2 3 7 2 3 5 2 3. This 2 3 is reoccurring after a breakup. Okay, this is fine. Okay, very fine. Okay, after a breakup, one decimal place. Okay, 2 3 is coming again and again. So this is non-terminating but recurring. Okay, so recurring decimals are like this kind. Okay, so non-terminating and non-recurring will be counted in the category of irrational number. Okay, not rational, irrational number. So the same case, okay, which is with 5 with 5 and 22 by 7. Many people are confused, okay, whether 5 is rational or irrational number. This Greek letter phi, okay, we spell it like this. So will is this phi rational or irrational number? Okay, people are usually teachers tells us that okay, pi is irrational number, okay, but on the other side, okay, teacher usually say that okay, phi equals to 22 by 7, but actually this is not equals to 22 by 7. Actually this is approximately equal to 22 by 7, not equal to 22 by 7. So whenever you will calculate your value of pi from Google calculator or from any other standard calculator, you will get the value of pi like this, okay, 3.1415926535897923 and this will be going on, okay. Now check it, okay, there is neither in this this decimal, okay, neither the number is recurring or terminating, okay. So this is the third case, okay, this will be counted in the category of irrational number, okay. This is going on, okay, to infinitely many decimal places and none of the number is recurring, okay, here in this case. But on the other side, okay, 22 by 7, okay, this is integer, this is again integer. We told that okay, when we write two integer as a fraction, this is called rational number, okay. So what will be the value of 5 by 2 when you will Google it or when you will check by your calculator, but a standard one which give you some precise value, okay. So when you will check 22 by 7, its value is 3.142857. This will be again, okay, will be non-terminating but recurring, okay. 14285 again, what will come? 14285 again, 14285. This will be going on, but the thing is that okay, this something is repeating again and again, so that's why this is called rational number, okay. Why? Because this is non-terminating but recurring. So second case is there. Here I have told you non-terminating and recurring are counted in the category of rational numbers. So this is the confusion which usually students have. So 22 by 7 is a rational number. Why is it so? Because clearly it is a fraction of two integers, okay, and both are relatively prime integers. So if this is a rational number, so why phi not is a rational number? Because phi is not equals to 22 by 7, but it is approximately equals to 22 by 7. So this was the confusion which I have tried to clear to the students. Usually they were asking about. So today I made a lecture about it, hoping that it would be quite helpful for you guys. Thanks. We'll see you guys next time, inshallah. Allah Hafiz.